Am I audible now?
Yes, ma'am.
Is it audible?
Yes, ma'am.
Okay, class. So, if my voice breaks or something, please just tell me. See, we started with the current electricity in the last class. All right, let's start with batteries. So, current we had seen, current density we have seen, drift velocity we have seen, Ohm's law we have seen, and variation with temperature also we have seen. Now, see, in case of battery, in battery you'll have an internal resistance along. Okay, what's EMF? Yes, what's EMF? This symbol EMF. See, you have terminal potential difference also, you have voltages also. So potential difference across the battery when it is not in use. This is how you can remember it. Easiest way to remember EMF. Now see, internal resistor is connected along with the EMF battery. Now this internal resistance, what is this internal resistance? This internal resistance is actually the resistance of the battery within, right? See, electrolytic solutions is present. Okay, Sana, let her join. Wait. Yeah, Upsana, is it audible now? Okay. See, when we're talking about the internal resistance means the resistance of the electrolytic solution and the electrodes within a battery. Now, what you need to remember is, in case of an open circuit, the current is 0. In discharging and charging, we have two different equations, E minus IR, and for charging, we have E plus IR. Okay. Now, this is the formula for the current. This is the value for the current. That is E by capital R plus small r. This is the formula for efficiency. Sometimes this is directly also used in the exam. When we are writing external resistance means all the net cumulative resistances. Okay. This means this is R equivalent, which has been mentioned. Every time it's not possible that you'll only get one single resistor as the external resistor. Right. So capital R means external resistance. Your external resistance can be the combination of parallel or the series one, right? Now see, if this is the formula, capital R divided by R plus small r into 100 for the percentage. So if we say the internal resistance of the battery is 0, let's say small r is equal to 0. So what will be the efficiency? See, if we make this term as 0, R by R will get cancelled, means efficiency will be 100%. So you need to remember that when can we get efficiency as 100%? When the internal resistor is offering no resistance. Okay, this has one come in the conceptual. Okay, now combination of resistances, series and parallel. This is very easy for you. Series combination. If I have to write the R equivalent, what's the formula for it? Yes,
R1 plus R2 plus R3.
yes, right. R1 plus R2 plus R3 and whatever be the number of resistors that are connected. Now, which quantity remains the same in series connection? Current or voltage?
Current.
Current. right? So here current will remain the same. Then we have parallel combination. Now parallel combination we reciprocally added. Like this will be 1 by R equivalent will be 1 by R1 plus 1 by R2 plus 1 by R3 up till whatever is the number of resistors connected. Now, if the resistors are identical, then divide the resistance by the number of the identical resistors which are put. This is also helpful, and this you already know. And here you should know that the voltage remains the same. Okay. Now coming to the combination of batteries. So in case of combination of batteries, see, these are various batteries that are put, and these are the internal resistances. So when you're asked to write, see, these are all connected in series. So when you are adding all the equivalent EMF, you will just add it E1 plus E2 plus E3 like this. Resistance, internal resistance equivalent. This in any ways will always be added. Resistance can never be subtracted. Resistance is also not negative. So resistance will be R1 plus R2 plus R3. Like in this case, let's say this can be continued further. But what if I reverse one of the batteries? See, E2, which was connected in series like this. Now I have reversed this one. See? So what we'll do for the equivalent resistance, this will have the different sign. E1 minus E2 plus E3. So R equivalent will be R1 plus R2 plus R3. R equivalent won't change. This will be changing. EMF can change. This can be negative. If most of the cells are connected in opposite, it can be negative. EMF, we know it can be, but internal resistance cannot. Now, there's a question that has come before. See, when n number of identical batteries are connected, E equivalent will be Ne, R equivalent will be Nr. This is easy for you to know. But if reverse happens, means n number of identical are connected, M is reversed. Like here, one was reversed. Let's say 10 batteries are connected which are identical and 2 have been reversed. So 10 will be N and the 2 which has been reversed will be M. So use this formula directly, N minus 2Me. Okay, this is a little important because the rest of the things, you know, R equivalent will still be NR. Tell me, is it clear till here?
Yes, ma'am.
Okay. Before starting with Wheatstone bridge, from this battery segment, just write the equation of discharging, charging, and this efficiency part. Okay. Done. Should I scroll it?
Yes, ma'am.
Okay. This you already know, combination of resistances, so no need to write this. From combination of batteries, just write down this identical part, identical and reversed part. This is used. So some direct questions have come that you will be able to manage them. Then I'll start with Wheatstone. Done.
Yes, ma'am.
Okay, coming to the Wheatstone Bridge part. See, Wheatstone Bridge you all have had in your syllabus. Yeah, Wheatstone Bridge was there. Meter bridge and potentiometer were deleted. So see, regarding Wheatstone Bridge, in Wheatstone Bridge, what's the condition? The potential difference here becomes zero. So there is no current that is flowing across this. So basically, if the value of current that is flowing is zero across this wire, you can simply remove it. So if you have removed this, if this is not present, these two will be in series, these two will be in series, and their resultant will be in parallel. But there's a condition for it. We cannot simply just use this. When can we say there is no current? When this P by Q is balancing R by S. So balancing condition has to be satisfied. Now there are certain modifications that are made using the Wheatstone bridge. Okay, what can be the modifications? One very common modification is this. But you have to be very careful because within this also, the questions are changed. One resistor is erased, one resistor is put again with it. So what you do in such questions like this one, this question, this is actually a Wheatstone bridge. So let's say this is point A and this is point B. Means if this is point A, this will be point A. And if this is point B, this will be point B, right? This is B, A, this is A, B. Okay, this was B, so along B. Okay, this has, and this is connected to another point. This will be then some point C. This will be the opposite point. Okay, A and B are put like this. So this one will be the, this is the first, just a minute. Yes, yes. Yeah, I was saying, no, this won't be point B. See, this is point B. Once we have, this is point A. Okay, this is point B that we have chosen. Now, you have to go by, this is called as the potential divider. Means across the same wire, the same potential will flow. For potential, remember, see, current divides on branch, right? Current will divide on branch. But when we are talking about the potential, potential doesn't change on branch. So when will the potential change? If a device comes. Device means your resistors, your capacitors. Okay, like that. Those devices change the potential. Like if I have a potential. So since this is a device here, let's say this is some C. Okay, and this is our point A. Now see, if you connect it back, if you check with the circuit, what exactly is this circuit? This is the Wheatstone bridge only. Means you need not include this. Let's say this is P, Q, R, and S have been put. So you can also put this as P, Q, R, S. And see across AC, these 2 points have put it as AC. So across AC, whatever will be present, no current will be flowing. So ultimately, what it has become? Two series connected to two series. So two series combination, they are connected in parallel. What all changes can be made? The rest other changes. Okay, look at this one. Okay, we have to go along the same wire, right? So here also we'll be going across the same wire. Okay, let's solve this also. Let's write this first in terms of all these. Let's go and solve this in terms of this. Let's say this is our main circuit, okay? So wherever you are connecting the battery, those points will be the extremities point. Yes, class. I was saying let's make this circuit equivalent to this. So if this comes in the exam, you'll be able to write this. Because some questions, the questions which I have written, these are from your previous years. So look, these 2 points, these are connected with the help of a battery. So it means this is my A point according to this example I'm referring. And this one will be the C point. Because see, I'll be able to connect a battery in between these two, right? I'll be able to connect a battery in between these two only. So this is point A. Now, if this is point A, this will be point A. Just keep on moving along this. Keep on moving along this. Same wire is there, same wire is there, same wire is there. Okay. This is point C. This is having the same wire, like this. So A and C points we have made, these are the extremities point, right? So even if I connect it like this, if I bend the wire, will it make any difference? Bending of wire, will it change your potential?
No.
No. Bending of wire won't change the potential. So what can change the potential? Just the device can change the potential. So if it's A, let's say this is the point B. Okay. So because this device has come, this is not the straight wire now. Let's say this is some point B, this point B. So in between A and B, what do we have? This will become your P. This P resistor which is connected, right? Similarly, C point is there, this is D point. So what all things are there? See, between A and D, R is there, so this will become R. Between D and C, this is D and C, this is S, so this will become S. Between B and C, Q is connected, so Q is connected, look. So this is, you can just write it like this and then solve it. This is clear?
Yes, ma'am.
Okay. Now let's come to the little modifications that have come. These 2 questions have come in the exam previously. So here, what's the difference? When you look at it at one go, this appears like a Wheatstone bridge. But here, if you see, this resistor is missing. So if the resistor is missing, if I say this is point A, this same wire throughout will have the point A only. This is the difference. Otherwise, because of the presence of the resistor, the voltage was changing. Right now, the voltage will be the same. So this will also be pointing. And here, if I have B, since device has come, this will become some point C. Let's say this is R1, this is R2, this is R3, this is R4. So what is this? How will I solve this? Let's assume some values are given. Right now, I'm just talking in terms of R1 and R2. So this is R1. Okay, this is R1, R2, R3, R4. These are present. So again, the 2 extremity points, here the 2 extremity points are A and B. Means between A and B, we have to fix up everything. Now, what all can we see from the question? Between A and B, what all things are there? See, R3 is present, right? Between A and B. Between A, see this point is A. And C, R1 is connected. So between A and C, let's make this. Between A and C, this R1 is connected. This is A, this is point C. Here, the problem in the previous section that we were discussing in the last class, those were very quick questions. Here, because in most of the questions, you have to redraw the circuits. You have to keep on redrawing them. So that's the difference that comes. Okay, so here you have to have a little patience in the circuit questions. Some of the questions I'll show you where you have to redraw the circuits multiple times. That will give you the answer. In most of the cases, you don't have to draw that. So this is A and C. This is R1, which is connected. Across A and C, again R2 is connected. This is, so it means this is connected in parallel, right? This is R2. Then between C and this is done. Then again between A and B, R3 is there. C and B, R4 is there. Means this will be R4. This point B which I chose, R4. And between A and B, R3 is there. So connect A and B, R4. So now this is easier to solve. These 2 are in parallel. This with the resultant in series, with the resultant in parallel. Will you be able to solve this one?
Yes, ma'am.
Okay.
Yes, ma'am.
Last, this one before moving on to the previous year questions that have come. Here in this question, both the wires. Okay, what do we call this? If such figure you see, not like this, but if I give you this, what is this called? Can you tell? Short circuit. This is the figure for short circuit. Here the issue is that this one. Here, this is not short circuit because here another wire is coming. In short circuit, basically, since a wire is connected, entire current flows through it and nothing flows through our device where we require. But here what will happen, even if the current is flowing through here, some amount of current will come through here. So this is not a short circuit. Okay. Anyways, linking it with what we were studying, how to make it as a circuit. See, again, we go by the potential divider method. This is A, this will be A. This is B, this will be B. So this is very simple. Between A and B, this is connected, let's say R1. Between B and A, this is connected R2. Between A and B, this is connected R3. Means between two points we have. A point is there and B point is there. R2 was there. Here R1. And lastly R3. So all of them are connected in parallel. Let's start with a question, but just make, no need to make this Wheatstone one, just make these two. This one and the other one, okay? Then I'll start with the questions. Class done?
Yes, ma'am.
Okay. Let's move on to the previous year questions that have come. So these are the recent questions only. 7th Jan 2020 shift 1. So see, This is that the current I1 in amperes flowing through 1 ohm resistor in the following circuit. Means these are 1 ohm resistors. What this is the figure directly given. I1 we have to calculate. Okay, see, how will we proceed here is, look, if this is saying the voltage is 1 volt, and this wire, this entire big wire, and this wire, both of these wires are connected in parallel, means across this also it will be 1 volt, and across this entire wire also it will be 1 volt, right? This will also be 1 volt and this will be 1 volt. So I can say, see, what's the equivalent resistance here? These two are connected in parallel, half plus 2, because it's connected in series. So equivalent will be 1 by 2 plus 2, which is 5 by 2 ohms. So I have the equivalent resistance as 2 ohms. What's the voltage? Voltage is 1 volt. So what will be the current total? Total current means total current throughout this, right? So I can use V is equal to IR. I will be equal to V by R. That is 1 by 2, and this 5 will go up. Oh, sorry. 5 and 2 will go up. So I get the current 2 by 5 amperes. But this 2 by 5 amperes is not the current that we are looking for. This is which current? This is the current across both of these combination. This combination and this combination. So the current will remain the same. If this is flowing as 2 by 5 here, it will be 2 by 5 here also, and it will be 2 by 5 here also, right? And what are we concerned with? We are concerned with just this part. So 2 by 5, see, these resistors are identical. Means the current will be divided into exactly 2 parts, because whatever, let's say I coming here, I1 and I2 both will be equal because these resistors are identical. So basically 2 by 5 for I1, 2 by 5 gets divided by 2. So 2 gets cancelled, 1 by 5, this is equal to 0.2 amperes. So C option. Easy. So these kinds of questions have come in your JEE. It's just that you need to, in such questions, these questions are easy. The calculation part is also fine. You just need to solve it in a very less span of time so that you can give the rest of the time to the good questions or the lengthy ones. Okay, just write it. Then we'll move to the next question. Written the question? Just tell me when you have written it.
Done, ma'am.
Okay, look, this question is also very, very simple. What do you think? How should we proceed? Like the easiest way. Just suggest me. I'll tell you how we have to go. What do you think? Anyone, Upsana or Meera, anyone, what do you think? How should we proceed? See, the best way to answer is it is saying a wire of resistance R, means a long straight wire must have been there whose resistance is capital R, right? It is bent to form a square ABCD. This is shown. So straight wire was there. It has bent in the form of a square. What is the total resistance of this figure, which is mentioned? Tell me this. What's the net resistance of this figure?
R.
R, exactly. The net resistance of this figure is R. So it means each of these arms will receive, this will receive R by 4, this will receive R by 4, this will receive R by 4, as well as this one, this will also receive R by 4, because it has been divided into 4 parts, 4 bending. Now what it is saying, E is at the midpoint, means this part will receive R by 8. Further, R by 4 is getting divided into 2 equal parts. So this is R by 8, this is R by 8, right? Now what it is saying? It is saying you have to calculate the effective resistance between E and C. Wherever effective resistance is asked, means you have to put a battery. How do you put a battery? Take the 2 points and then connect them with the battery. So it means these are connected in. See, this is the wire now. Look, this is one single wire till here. And this is the second wire. Take them as resistors. Wait. Look, this is a resistor now having resistance R by 4. R by 4, R by 4, and this is R by 8. Right? This is one end of the battery, E point. This is one straight wire till here. And between the E point and C point, there is another resistor connected like this. So can you now figure parallel and series combination, which are at least this much you should be able to do now? Okay, tell me, draw it, draw this. You have already written the question. Write it what I have told you. Now tell me what's the equivalent resistance between E and C. I have given you the hint also, and this also I have told you. Now you tell. I'll tell you the options then. This question had options. Yes, right. Meera, correct. Option B. See, now these are within the same wire, means they are connected in series. This R by 8, look, this R by 8 and these R by 4 plus R by 4 plus R by 4 plus R by 4. This becomes 3R by 4, so plus R by 8, that is 7R by 8. Now 7R by 8 and R by 8, they are connected in parallel. So 7R by 8 into R by 8 divided by 7R by 8 plus R by 8, that is R. So R gets cancelled. 7 by 64. 1 R will remain, this R. So answer will be two. Okay. Upsana, have you also done or you need to write?
Yes, ma'am, done.
Okay. Let's move to the next question. Now we are moving towards the switch questions. Okay. This question completely, I'll tell you. The next question, which we are going to do, question 3. Question 4, you will try. Okay. It's very easy. Switch-based questions, how you need to solve the switch-based question. See, this says that the ratio of the equivalent resistance of the network between points A and B means between this point A and this point B. A और B दोनों के बीच में equivalent resistance निकाला गया. And what is it? It is saying that when the switch is closed, then the equivalent resistance is calculated. And when the switch is opened, then the equivalent resistance is calculated. This is a question from your 2021 paper. It is saying when you take that open switch and closed switch part, you take that ratio, you get X is to 8. What's the question? Question is saying once initially the switch is open and all the resistors are connected. Okay. Switch is open, net resistance is calculated. Switch is closed, net resistance is calculated. So what will be the equivalent resistance in case of open and closed? This you need to know. And once you have them, you take the ratio. That ratio is given to us. That is X is to 8. So we need to calculate X. Means what do we have to find out? When you have the open switch, across open switch, will there be any flow of current? There won't be any flow of current. Switch is open, current is not moving. So what you do in such cases, draw two figures. One with the open switch. R is there. Next one is 2R. This was 2R and R again. This is 2R and this is R. This is 2R, this is R. Now look, when this was given to us, switch is now open, means no current is flowing, means I can delete this. So what am I left with? What kind of circuit is this? Very easy. These two are connected in series. These two are connected in series. They result in connected to parallel, similar to that of a Wheatstone bridge. So this becomes 3R. This becomes 3R. Equivalent resistance will become 3R by 2. Why? Both of them are identical. They are 2 in number. So equivalent resistance divided by number, 3R by 2. Now, when it says the switch is open, so open switch, what does it do? How does it harm your circuit? The open switch simply allows the current to move through it, means it will act as a straight wire. This is R, this is 2R, this is 2R, this is R, and this is B and A point. Now, if current is flowing across a wire, we can simply draw it like this wire. So what kind of circuit is this now? Now again, this circuit you'll be able to solve. How? Look, these two are connected in parallel. These two are connected in parallel. Their resultant will be connected in series. So it's better if you draw it like this. See, this will be somewhat like this. This is one resistor R, right? This is the 2R1 connected in parallel. This is 2R connected with R like this. Like this. Now this is easier to solve. No? R, 2R. So R and 2R, this will make 2R by 3, right? These two will make 2R by 3. 2r by 3, 2r by 3 connected in series. You can simply double it because you are adding it. So R equivalent will be, if you double it, this will become 4r by 3. Like this, you have to perform the calculation quickly. Now we need to take up the ratio. What did we get in the open case? 3r by 2. So you take the ratio. Basically, RA by RB means first to the second one will be. It was 3r by 2. 3r by 2 into. This is 4r by 3. So 4r by 3 goes up. R gets cancelled. This is 9 by 8. X is to 8 means 9 is to 8. So your x is equal to 9. Is this clear? I'm just repeating it once. Understand? And if you have any doubts, you take. Switch-based questions are asked a lot in the JEE exam. JEE mains exam, switch-based questions are often asked. So what's the issue here, or what's the condition here is this only. Open switch, you remove the wire. So you have removed the wire. What did you get? When the wire was removed, these became in series, these became in parallel, and resultant was in parallel. And when you have the wire, the current is flowing, then opposite happens. These two become in parallel, these two become parallel connected, and the resultant becomes connected in series. You take the ratio, you get the value of x. Tell me, is this question clear? Both of you, Meera and Apsana?
Yes, ma'am.
Yes, ma'am.
So write down this question, and then the next question you are going to tell. It's a similar question that has come in the exam. First write it and keep on texting me done so that I know how much you have written.
Done, ma'am.
Okay, now you write this question, try it, whatever answers you're getting. Tell me in the chat column. Similar question, easy question now for you. And this is from your previous year only. I have not mentioned the year, I forgot. I think this is from your 2021 only. So just try whatever is the answer, whatever the answer is coming, tell me in the chat column, both of you. Then I'll discuss. Okay, yes, both of you have got it correctly. 10 ohms. So same procedure. You have to take the open circuit. So in the open circuit, these three will become connected in series, right? 12 plus 4 plus 6. And again here also 12 plus 4 plus 6. You divide it by 2, you get the value. right? And in case of parallel, now one thing I'll just tell you, however you have solved it, in case of parallel connections, it's better if you draw it like this. In the switch cases, in these questions. Like this, you'll have a very good clarity what you have to solve. These two are connected in parallel, rest are connected in series. Otherwise, if you draw like this, you will think that these two are connected in parallel because of the wire. So this sometimes appears, though the wire is same, so it is in series connection. Okay. Yes. So this says that first, a set of n equal resistors of 10 ohm each are connected in series to a battery of EMF 20 volt. Internal resistance is given as 10 ohm, right? A current I is observed to flow. Then n resistors are connected in parallel in the same battery. Means initially they are connected in series, then they are connected in parallel. And we need to find out the value of current, right? Now, it is also saying one thing that the second value of current is 20 times the first one. See how we have to solve. What the question is saying, let's understand that first. This is a question from your 2021, 27th August, shift 1. See, a set of n equal resistors of 10 ohm each are connected in series. So if this is the case, let's go step by step and keep on drawing it together. Let's say these are all the 10 resistors which are connected, okay? And this is connected to the battery. So if 10 ohm resistors are connected in series, N is the number, what will be the equivalent resistance? 10 resistors and N number. Means 1, 2, 3, they are N. Yes, Upsana?
NR.
NR, right? So that is 10 into N. Voltage is given or not? Yeah, 20 volt voltage is given and internal resistance 10 ohm is given. Means this is 10 volt and 10 ohm. And across this some current I is flowing. Let's say this is I1. Now, if this is the case, what is the value of I1? I told you this will be EMF divided by R plus R. What is the EMF? 10. R means capital R, external resistance. What is it? N into 10 plus small internal resistance means the value of the small r, that is internal resistance. So this will be 10. So if we take 10 common from here, this will be 10 divided by 10 into n plus 1, right? This is what we'll be left with. So 10 gets cancelled. I1 is equal to 1 by n plus 1. We cannot solve this further. Let's read the statements further. This says that now, internal resistance and voltage. A current I is observed to flow. That has flown. Okay, this is I, not I1. So I'll also make this as I. It's given in the question that the value is I. All right. Now the question is saying that these resistors are connected in parallel and same thing is observed. That is the current is observed. Now you tell what should be the equivalent resistance. All these are connected in parallel. I'm writing the equivalent one. Yes, what will be the equivalent resistance?
10 by N.
10 by N, right? This will be 10 by N this time. This is 10 volt, 10 ohm. And here, let's say I2 is flowing. The amount of current that is flowing is I2 because I was there initially. So same thing, current will be calculated in the same and similar manner, right? How will we calculate the value of current? Current will be calculated by 10 divided by 10 by N plus 10. This is the difference. So again, 10 will be cancelled. Anyway, this will be 10, 10, 1 by N plus 1, right? 10 gets cancelled. This denominator becomes N. So N goes up and we'll be left with 1 plus N. This also cannot be solved further. Now you tell what should we do. I cannot be solved further. I2 cannot be solved further. Now, how will we get the value of n? Hmm? Read the question. Anything that you think can be added or can be utilized to get the value of n. See, we cannot solve for the 1 by n plus 1 or n by n plus 1. This cannot be solved further. We are stuck here. Then, yes, Meera, you want to try?
Ma'am, is it like I in series is 20 times that of I in parallel?
No, but you're close. Look, we'll use this 20 times only. This is saying it is observed that the current is increased 20 times. So as Meera was saying, series connection and parallel connection, they are 20, the ratio is 20. So yes, you're right. Your series connections current will be 20 into the parallel connection. You get the value of n. One variable was only missing. Means we can say here that value of I will be 20 times value of I2, right? No, this is saying the value of I, this is the series connection, right? So this is reversed. It's previous is I2. Yeah, we have chosen I2 as the new current. Na? So for parallel current, the parallel current will be 20 times the initial gas. This is the statement that is given. So we'll utilize this only. Now, the new current that we have got is n by n plus 1, 20 into, this is 1 by n plus 1. Easy. N plus 1, n plus 1 gets cancelled. N becomes equal to 20. So this took a lot of time to solve because I was discussing, but when you have the command to this question will not take much time. Okay. All right, you write down this question. Okay, just one thing I forgot to mention. Your chemistry class won't be there today. Okay, the chemistry class won't be there. There's a death in the family, so we won't be able to take the class. You will have your maths class directly from 5 p.m. I think it's told. So from 5 p.m. only you'll have the maths class. So instead of chemistry, we'll just have half an hour more class. Like the duration of today's physics class will be of 2 hours.
Ma'am, in the question, the EMF is given as 20 volt, right? But we have solved it by taking 10 volt.
Uh, in a battery of connected. Oh, yes, yes, yes. This has mentioned as 20 volt, right? Let me check whether I think it's 20 volt only. We have to change our answer. Just wait, let me still confirm with this. Yeah, this is 20 volt only. We'll take it as 20 here. I took 10 here, na? That's it. So this will be 20 volt and 10 ohms. 20 volt, 10 ohms, 20 And here also 20. So I think our answer will be different now. Okay, anyways, the 20 will be cancelled. Okay, so we'll still get 20. So it means in this, whatever is the number of times mentioned, right? Here the number of times, this is 10 and this is 20. So this is given. Okay, just wait. No, it's actually 10. It's a misprint in the question part that I've written. Okay, just change it there. I think you've not written the solution. Change it there only. So this will become 20. Just change this to 10 volt. This is 10 volt. So it means whatever is this value will be the answer. Whatever is this value given. Okay, let me discuss it. It's also a very easy question. See, actually, the questions are not very difficult that come in the exam, in the entrances. But the problem is that during that state of mind with which you are appearing for the exam, that makes the questions tough. So this is slightly easy. See, this says that a uniform metallic wire has a resistance of 18 ohm. So both of you are appearing for the JEE for the first time, or is it any second or third attempt?
Second time, ma'am.
Second time. And
The
Ruxana?
section.
Both of
Second, ma'am.
Okay. So this was your drop year.
No, ma'am, I gave it in the first attempt when I was in 12th. So, yeah, along 12th.
Okay. Okay. So how was it? How was the score? It was fine.
No, it was just an attempt. So,
We did not prepare so much.
Uh, uh, see, this says that a uniform metallic wire has a resistance of 18 ohm. So means again, the way that we have done that question, total resistance was R. So it's a similar question and it's an easier one because now 3 sides are only there. In that 4 sides were there, square was there. So now an equilateral triangle is made. So see, this is one side. Okay, so see, this is one side of the figure. This is the second side, and you have the third side. So all the resistance are connected. So now total resistance is given as 18 ohm, means 6 ohm, 6 ohm, 6 ohm per. Now this is saying that between any two, means let's say this one and let's say this one. So whenever it says between any two means you have to insert insert a battery, right? So look, how will we solve this? These two are connected in series, right? And again connected with parallel. So this is 12, this is 6. So you know the answer. What's the answer? See, options are there. Like this, when you draw the figure no, in the exam. See, if you solve it like this, these are 12. And if you solve it like this, 12 into 6 divided by 12 plus 6, then you are further solving everything. So see, when you look at the options 12, 8, 2, 4, should be clear. The answer is 4. Okay. So these kinds of questions are there. And okay, this we'll see. Write down this also. Make this also, so that you know. And this, see, when you see these questions, when you see 12, when you see this calculation should be quickly done in the mind. Okay, so you can then further write this. Just write down this and I'll show you the next question. Okay, you're done. Let's move to this. This is a good question. This says that a metallic wire, so similar pattern only, but with little modification. This has come in the JEE Mains 2019, 9th April. So this says that a metallic wire of resistance 3 ohm is elongated to make a uniform wire of double its previous length. Now, which relation should we apply here? See, as soon as you see resistance and length, in the last class, I made you write this relationship. R is directly proportional to square of L. This is very important. It's a very easy relation, but it's very helpful in the numericals for the competitive exams, because it will not waste your time. See, if 3 ohm resistance is there. So when you say, this is saying a metallic wire, let's say this wire is there, the resistance is 3 ohm. Now, the length has been doubled. So if length has been doubled, means the resistance will become how much time? How much times will the resistance become if length is doubled? Tell?
4 times.
4 times, correct. So for you, it's very easy now. 1 was 3 ohms, now 4 will be 4 into 3, that is 12 ohms. Means now the length is doubled. So our resistance, which is directly proportional to the length, now the new resistance will be 4 times the previous resistance. So now when you have elongated wire, it will be 4 times the previous one, that is 12 ohm. Some things have been solved right there and there. Then this says this new wire is now bent, and this time it forms a circle. So what all figures we have seen? Square we have seen, triangle we have seen, and now we are seeing a circle. So if it is saying, okay, this wire is there and this is bent in the form of a circle. Okay, now what all things the question is mentioning? It is saying, see, this has been bent in the form of circle. What are the rest of the instructions? If 2 points make 60° at the center, okay, 2 points make 60° at the center of the circle. So if 60° has been made by one, and this is saying what will be the equivalent resistance between them. So basically this is saying that, let's say this is 60°. So what will this part be? 300? 300 बचेगा ना? Total 360 है. 60° निकाल लिया. 300 degrees बचेगा. So you have 300 and here this is 60. Let's say this is connected here to the wire. Now the problem is that angle has been mentioned, but we don't need the angle anywhere. Any formula, do you remember any formula where theta is used in resistance? Anything you're able to recall? Theta with resistance? No, because it isn't. Angles, we will relate this with again with length. Means when 3 ohm was there, we got total 12 ohm. Now what is this? This total is now for 12 ohms, right? Total new resistance that we have is 12 ohms. Now we have to see the ratio now. Okay, 60 and 300. If total is 360°, and I have taken out 60° from here, and rest of the 300 degrees are put. Now I have to see, I have to divide 12 in this ratio. Got it? I have to divide 12 in this ratio. So it's very simple. See, 60 into 6 gives us 360. Right? Means if I have 60° plus 60° plus 60 plus 60 plus 60, I'll get my 360° back. So it means this has been 1/6 has been taken out. So of 12, if you take 1/6, 12 ohm is there, total 12 ohm is there. Now I am taking 1/6. right? So if 60 degree is taken, 60 into 6 is 360. Means out of total 60 degree has been taken. 1/6 of a circle has been taken. So how much this part will receive? 2 ohm. Did you understand this step?
Yes, ma'am.
Yes, ma'am.
So this is 2 ohms. If this is 2 ohms, you can use the unitary method also, or you can use simple subtraction. From 12, 2 ohm has gone, 10 ohm is left. That's it. This is what the question required. Now the question is very simple for you. I think the answer would be 5/3. 10 into, this will become, see now R equivalent will become 10 into 2 by 10 plus 2. So this becomes 20 divided by 12, right? 5/3. Yes. So this will be the answer. Write it. Okay. See, this is a previous question from 1998 JEE advanced question. Okay, not from your mains. But the question is simple, and these kinds of questions after then come in the regular exam also. So see, the solving this first, you need to find out the current. Then we'll be able to calculate anything because voltage is there. So we require the current. It because it has ultimately asked us the current. So see, these three are connected in series, right? If these three are connected in series means 4 plus 2 plus 2, that is 8. So I can say this is 3, this is 2. This is 9 volt. This is 2 volt. And this is also 2 and this is 8. Okay, this wire I'll tell you. This is 8 ohm and this is 8. Okay, so this is 2, this is 2. Here we have 8. Okay, and now see 2, 2. This is 8 is there. The 2 ohm, 2 ohm and 4 ohm. This can be now put as 8 ohm, right? Then now these 8 ohm, 8 ohm, these are connected in parallel. So this 8 ohm will become 4. So what we'll have? We'll have this. We'll have this 8 ohm. We'll have this 2 ohm. I've written 2 volt. This is 2 ohm only. This is 9 volt. This is 3. This is 8. This is 2. This is 2. Now, instead of this 8 and 8, I can put this as 4. Right? Now, again, see, this is repeating. Same thing. 2, 4, and 2. They are again making 8. When 8 and 8, but we need to redraw the circuit here. I'll tell you why. Because this question will take a little time. We require to draw it. Otherwise, we can find the, if it was the question of finding the net equivalent resistance of the circuit, you could have directly done it. But since we want to find out which out of all these splits and divisions we have done, which is giving us the exact amount of current. So for that, this is 2, this is 8, and we have again put an 8 over here. Now, this 8 and 8, these are giving back to 4. So what do we have? This is 3, 9 volt, 2 ohm, 3 ohm, and finally we have 4 ohm. What's the current of this circuit? See, 3 plus 2, 5 plus 4, 9. R equivalent is 9 ohm. V is 9 volt. So current will be 1 amperes. Okay. So it means current is 1 ampere. Now pay close attention to this. How to solve this question easily. Look, it means 1 amperes of current is coming. Focus on this 4. So this 4 or this 3. See, firstly, it is saying current through 3 ohm resistor is 0.5, 0.2. Both are cancelled. Means we have to focus on 4 ohm. But the problem is that, is this 4 ohm independent? Can I say 4 ohm has 1 amperes current? No, this has been made up by all of these. Means these two. This will become 1 by 2, 1 by 2. Right? Do you get this? This will become 1 by 2, 1 by 2. These rest of these are connected in series. So this will receive 1 by 2, 1 by 2, 1 by 2 still because these are connected in series. But when you come to here, this will again become 1 by 4, 1 by 4. Right? So what is it? Ultimately, this is the value across of the current. So basically 1 ampere came from here. 1 ampere came. It got divided into 1 by 2, 1 by 2. And it got divided into 1 by 4. So option is D. That is current will be 0.25 amperes because it is 1 by 4. Is it clear? Did you get the shortest way to solve such kind of questions? Did you understand, both of you, Meera and Upsana?
Yes, ma'am.
कुछ
Yes,
पूछना है
ma'am.
इसमें?
No, ma'am. Clear.
Okay. Right. Then one more question is left. Okay, one last question. So, this is from your 2023, very recent, but the question is fine. The R equivalent between A and B. Look, is the condition of Wheatstone bridge satisfied? Because see, don't look at these trapezius like figure. This is a Wheatstone bridge if the condition, balancing condition is satisfied. So see, R by 2R is 1 by 2 and 3R by 6R is 1 by 2. Balancing condition, as soon as it is satisfied, you remove this. These two are connected in series. So this becomes 3R. These two are connected in series. So this becomes 9R. 9R and 6R, no, 3R. 9R and 3 are connected in parallel, right? Series so basically, which device is this? Wheatstone bridge. It's a Wheatstone bridge. So very recently, it has come, right? 2023. Okay, write it. Do solve this further also. Don't leave the answers at this step. So you have 9R and it was 3R, right? So get the equivalent resistance 9R into 3R divided by 9R plus 3R. So from here, your 1R will be left. And this is 27R by 12R, right? R square. So 1R will be left, right? So you'll get class, can we have the chemistry class today at 7 p.m. IST? If you both are available, just let me know in the chat column because right now your class couldn't happen. If at 7 p.m. IST you are available, tell. Then the class can be put. Just say a yes or no in the chat column. Okay, Meera is available. What about you, Apsana?
Yes, ma'am.
You're also available? Okay, then I'll tell them. Okay, one question was, yeah, this question is very easy. I was saying that this question came in 2001 JEE Advanced. Now look, in this question, this resistor, this is R1, R2, R3, R4, R5. Basically, it is saying in the given circuit, it is observed that the values of current, this is R6. It is observed that the current I is independent of the values of resistance R6. So if it is saying, see, current I is independent of the value of resistance R6, means the question is very simple. This is not present. You remove it. So what kind of circuit is it? It's again a Wheatstone bridge. This part is Wheatstone bridge. Forget R5. You don't need to calculate the equivalent resistance. Why? Because look at the options. These are the options. So here, simply if it is saying that I is independent of the value of the resistance R6, means the Wheatstone bridge condition is satisfied. So you can say R1 into R4 is 2 into R3, because this is what? This is the balancing condition of the Wheatstone bridge. Did you get this?
Yes, ma'am.
Okay,
Yes,
so
ma'am.
easy one from JEE. So electrical power and all these electrical home appliances and all Kirchhoff's law. This I'll discuss. Now I need one more class on current electricity. And if time is permitted, then I'll start with magnetics. Okay, because see, in 2 classes, it was a little difficult to complete current electricity. One more class, I'll be wrapping up with current electricity. I think most probably in the next class, I'll try to start with magnetics. Your conversion of galvanometer into ammeter is also left. Kirchhoff's law and all these topics are only left from this. So in the next class, I'll wind that and I'll be continuing with magnetics. Your vectors were vectors completed?
No, ma'am.